Hi guys, this is Virtual Precalculus. I'm going to work through some problems that you guys worked on in section 8.3. It seemed like some of you needed a little bit of extra guidance for these problems, so if you want you can fast forward to the problem that you're interested in, or you can watch them all. It's up to you. Alright. Problem 9. We're supposed to use Snell's law, which is an idea from physics. Sine theta 1 over sine theta 2 equals v1 over v2. And that ratio v1 over v2 is also known as the index of refraction. We were told that that was 1.33 for this case, and we were also told that theta 1 equals 38 degrees. So just plugging in everything we know, we end up with this equation on the second line. Rearranging, what we can essentially do is the sine theta 2 and the 1.33 can switch places. If you don't like that, think of 1.33 as 1.33 over 1 and cross multiply, and you'll get to the same place that I do in line 4. In line 4 we end up having to use an inverse sine to get any further. We can use the calculator in degree mode to get an answer in degrees, 27.6 degrees. We could find answers in other quadrants that are equivalent, but looking at the picture we know that the angle must be less than 90 degrees. In 21, secant of x equals negative 2.65. We don't have an inverse secant button on the calc, so we need to think about things in terms of cosine. So secant is 1 over cosine, and we can rearrange that equation in line 2 to look like line 3. Again, think about the cross multiplication trick if you need to. Negative 2.65 is just negative 2.65 over 1. Anyway, we end up finding out that the cosine of this angle is negative 0.377. So using inverse cosine, we get an answer of 1.958 radians. Now the way cosine works, the other answer, the equivalent one, is always going to be negative of the original answer that you get from your calculator. So 1.958 and negative 1.958 plus k times 2 pi. In number 25 we have 2 times the cosine of x over 2 equals root 2. The first thing I want to do is isolate the cosine expression. So I can do that by dividing by 2. Cosine of x over 2 is root 2 over 2. That's starting to look very familiar. It might help to think about x over 2 as a new variable u, like I've written in red. And then all we're doing is solving cos u equals root 2 over 2. Well, we know how to do that. We just inverse cosine root 2 over 2, or we can just think about the special angles that we know about. This has got to be plus or minus pi over 4. Then, of course, we could add any integer multiple of 2 pi to that. So we can represent that by k times 2 pi. But u is x over 2. So to find x, we have to double everything. So x is going to be plus or minus pi over 2 plus k times 4 pi. Number 39. It might be tempting to divide by cosine of x. What that's going to do is it's going to remove any chance of us finding out that cosine of x might be 0. Dividing by 0 ends up doing strange things to the equation. So a better technique is to put everything on one side and factor out the cosine x, which is, as you can see, what I've done. Once you have the equation factored like that, then in my red arrows I've shown you that there are 2 aspects to your solution. Either cosine x is 0 or cosecant x minus 2 is 0. Cosine x being 0 is easy to solve, and in this set of problems we're asked to only find the solutions between x equals 0 and 2 pi, so pi over 2 and 3 pi over 2, that's enough. In the second set, we have cosecant of x equal to 2. Well, the reciprocal of cosecant is sine, and the reciprocal of 2 is a half, so we're really looking for where sine is a half. And again, within 0 to 2 pi, the answers are pi over 6 and 5 pi over 6. 41 is kind of overwhelming, but they do give you a good hint. So I just wrote down their hint. I put the factor tan x plus 5, and I thought about what could go in the next factor to make it work out. If you just look at the first term of the given equation, you see that tan x has been multiplied by 4 sine x. So I use that as a hint that the first term in the second factor must be 4 sine x. And then all the pieces fell together if I put a minus 3 in the second part. So once it's factored, then again you know that each factor could separately be equal to 0, and you can see, following through what I've done, what that means. Now the first answer we get for the left branch of this solution set is that x is negative 1.373. But we're meant to find solutions between x is 0 and 2 pi. And since this one came from an inverse tangent, we can just add pi as many times as we want to find all the positive values between 0 and 2 pi. In the other branch, we end up with 0.848, and we know that for sine, to find an equivalent solution, what we need to do is subtract pi minus the original solution. If you look at the unit circle and the way the quadrants are arranged, you'll understand how that works, I think. In number 47, what we want to do is put everything on the left side and factor. But when we try to factor it, we find that it doesn't factor. And so we end up having to use the quadratic formula. It helps me to think of tan x as a variable u. Replacing it, we see that it's not too hard to apply the quadratic formula. It's a bit ugly. We end up with u is equal to 3 plus or minus root of 17 over 4. And remember that that's tan x. So we need to inverse tangent that nightmare. Okay, and when we do that, again, the solution that we get, we can always add pi to that to find more. And again, the second solution that we get is negative. We don't want that. We want solutions between 0 and 2 pi. So we keep adding pi until we get all the solutions we need, and I've boxed them. In 49 and 51, we want to use the Pythagorean identity that 1 plus tan squared of x is equal to secant squared of x. And what I'm doing is I'm just going to replace the secant squared of x wherever I see it. So in 49, that changes the equation to look like it does in the second black line. 1 plus tan squared minus 2 tan squared equals 0. Simplifying and solving for tan, I find that tan has to be plus or minus 1. Okay, because the square root of 1 is either plus 1 or minus 1. Well, there are 4 places in the unit circle where that happens. Check out the butterfly diagram in the top right. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, in 51, the same trick happens, but we end up having to factor it, and we get our two factors separately being equal to 0. Inverse tangenting negative 2, we get a negative answer. Once again, we only want answers between 0 and 2 pi, so we just keep adding pi until we get all the answers we want. Now, the book missed the 2 answers on the bottom left, so if your answers don't agree exactly with the book's, that may not be entirely your fault. I think the book only got the 2 answers on the right side, but the 2 answers on the left are also correct, so don't forget those. And lastly, number 55. We're given the equation d as a function of t to describe the distance. We know that the distance has to be 0, and we're looking for the time. Well, 5 can't be 0, so it must be that the thing in brackets is 0. Putting the sine on one side and the cosine on the other side, and then dividing both sides by the cosine, we end up that tangent of 6t has to be 4, because sine of 6t over cosine of 6t is tan of 6t. So we find that 6t is the inverse tan of 4, and we can find out what that is. It's 1.326 plus any integer multiple of pi. Dividing everything by 6, we end up with 0.221 plus k times pi over 6. And these are the first 4 of those, and those are the ones that are between 0 and 2 seconds, which are the answers that they asked for. Alright, that's it, guys. Please feel free to rewind and watch this again. I know I talk fast. If you still need more help, please contact me. Good luck.